I can't resist dodgy looking Chinese products, and this one was no exception. A so-called scanner antenna covering a massive bandwidth of 30 to 1000 megahertz. As usual, the specifications tell you everything you don't need to know, but notice 30 meg to 1200 meg receive range, 50 watt power handling. They don't say at what frequency though. The package came fairly quickly, although it was described as an antenna, which is true. Inside the package was a plastic bag containing the aerial, and that's what it looks like. And sure enough, it was about the sort of size that they said it was, and the backside had got some sticky tape on it, and it had a BNC plug on it, and loads of RG174 just as described. I don't know how much that was, I'll measure it in a minute. You can see that it's helically wound, but unless there's an active element in there, there's no way that can cover 30 megs on receive, and there's no indication of there being any power supply. Incidentally, the markings on the RG174 are identical to those on the mini whip that had the faulty coax. It's probably aluminium. The question is, where does this thing resonate? Time to call in the trusty Nano VNA. I've set this thing up in a window, and I'm now going to test it with the Nano VNA. I've set the Nano VNA to sweep from 30 to 900 megs. It won't go any further, and I've calibrated it. Now we connect the antenna. This is the trace with the antenna connected. It shows the SWR in yellow from high on the left to low on the right, and the green trace is the reflection coefficient. Notice how there's no real dip in the SWR or the reflection coefficient between 30 and 900 megahertz. All of these little wiggles are caused by cable resonances, when the cable is an exact multiple of a half wavelength. You can see the general trend is downwards from low frequency to high frequency, the cable getting more lossy with increased frequency. And as it gets more lossy, the SWR improves. Now watch what happens when I move my hand close to the aerial. You can see, look, the resonance is now starting to move lower as the capacitance increases from my hand. And as I grab it, I can move the resonance quite low in frequency. So this thing does have a resonance. It's just well above the 900 megs of the Nano VNA. I think this is an ADS-B aerial. So does this thing actually work as a scanner aerial? Let's test it. This is the Malachite SDR on a whip aerial.
2022. That's why we're proud to launch Buy One Give One for every.
And now we try it with this so-called scanner antenna connected.
Norwegian fjords, and from October there's no fly cruising from Dover.
The previous result was just typical of what you would find at any frequency. The aerial is just no good compared to a proper aerial for the particular frequency. So let's just consider what it's like at 30 megahertz. This is the rough equivalent circuit of the dipole, the coax, and the receiver input impedance of 50 ohms, which we can replace with the following equivalent circuit, where we have the source voltage, which is the signal picked up by the aerial, the radiation resistance, the loss resistance, both of these are incredibly small. Well, the radiation resistance is small, the loss is reasonable, but there's the load impedance. But the reactance, the capacitive reactance of the aerial is 13,700 ohms approximately at 30 megahertz. So as a crude approximation, we can replace the reactance with resistance. It's only a crude approximation. Makes the math simpler, but you've got a potential divider with the capacitive reactance as the top half and the input impedance of the receiver as the bottom half, and when you work it out, only 0.3% of the input signal reaches the receiver, which is a very small amount. In fact, when you work it out, the gain is minus 50 dB. Now, you wouldn't go out to buy an aerial with a gain of minus 50 dB, would you? It certainly isn't the 3 dB that they claim. Now, I don't think the product itself is a scam. I mean, it's fairly well made. Obviously been made for a purpose, but that purpose is not a scanner antenna. This has been made for something else. And judging by where it resonates, I would say that this is an ADS-B antenna. And when you look on the web, you do find some very similar devices to this sold for the aviation industry. Let's look at some of the claims. Is it 50 ohms? Well, yes, at 1050 megahertz perhaps, but at any other frequency it won't be 50 ohms. The actual dipole is an electrically short helically wound dipole. It will have a capacitive reactance at frequencies anything less than its resonant frequency, and that will be translated by the cable to a variable impedance at the feed point here. So no, it's not 50 ohms. Is it 30 to 1200 megahertz? Again, no. It's too short for 30 megahertz, way too short for 30 megahertz. It has a gain of minus 50 dB at 30 megahertz. If that is, this thing's only really usable, I would have said from 800 megahertz to 1200 as a receive antenna. Will it handle 50 watts? I wouldn't like to stick 50 watts up that. Even on its actual design frequency, I don't think I'd like to stick 50 watts up that for any length of time. If you were to try and stick 50 watts up it at anything less than its design frequency, you'd probably blow your radio up because the SWR would be absolutely terrible. So, has it got a gain of 3 dB? No, certainly hasn't. On its design frequency, it can't have any more than a 2.1 dB gain over an isotropic. So, at any other frequency, it's going to be less than that. Is this a scanner antenna? No, not unless you're interested in frequencies around about 1050 megahertz. So pretty much everything they've claimed is wrong. It's another case of eBay mis-selling. And if you paid £4.67 or whatever it was for this as a scanner antenna, you've been ripped off. Bye.